Welcome back to Izzo Math. Now we're going to try another problem here that's a little bit more challenging, using comparing two accounts, one with compound interest, one with continuous interest. We have one bank account that pays 5% annual interest compounded once per year. So let's say that one's going to be, let me call that P sub 1 of T equals, so 5% compounded once per year, so that's going to be initial investment P naught times 1 plus R over N, but N is compounded once per year, so N is 1, R raised to the NT, and N is 1 again, so it's just T. Okay, we have a second account here that pays 5% continuously, and both accounts are going to start with the same initial amount. So I'm going to call that account P2 of T equals P naught times E to the RT. Okay, so that's our two accounts, and what we want to know is how long will it take for the second account to contain twice the amount of the first account. That is, how long will it take for this account here to be twice that account. That is, how long will it take for P naught E to the RT, and let me go on 0.05 T, that's the second account, to equal twice the first account, P naught 1 plus 0.05 raised to the T. Okay, so this statement right here says that this account is going to be twice the first account, so we just multiply it by 2. Alright, so the first thing we do here is we see that we have a common factor of P naught on both sides. P naught, and they're gone. And so we get that E, and let me come over here now. So we get the E to the 0.05 T equals 2 times 1 plus 0.05. I should have just added that 1.05, but anyway, we'll do it next time. Raised to the T. And the key here is you've got, I want to solve for T, and T is in, there's a point there, T is in exponents. So anytime, using our nice properties of logarithms, when we have things in an exponent, if we want to get them out, take the logarithm both sides. Take any logarithm you want, but typically we're going to take the natural log. ln, because we have a natural log button on our calculator. You could take log base 2, but you don't have a log base 2 button on your calculator. So take the ln of E to the 0.05 T equals the ln of 2 times 1.05 raised to the T. Remember, we can do anything we want to a math equation as long as we do it to both sides. That is, we can add 2 to both sides, we can subtract 10 from both sides, or we can take the natural logarithm of both sides. So this one is going to pop out the 0.05 T, and well, let me go ahead and write in there ln of V, but note that you should be thinking ln of V is going to be 1 equals, and we have some factors here, so it's going to be the ln of 2 plus the ln of 1.05 raised to the T, and so I'm left here with 0.05 T equals the ln of 2, properties of logarithms. That was my whole point. I wanted to get that T out of exponents, so plus T times the ln of 1.05. Okay? Let me go in this little box now. I'll change colors just for fun. And so now we're back to just regular algebra. I want to solve for T, so I want to get all my T's on one side. So I'm going to take this expression over to the other side and get 0.05 T minus T times the ln of 1.05. 0.05 equals the ln of 2. Alright, now factoring out this common factor of t, I get t times 0.05 minus the ln of 1.05 equals the ln of 2. And now I can solve for t. And to solve for t, I divide out by this term here. So we divide out by 0.05 minus the ln of 1.05. And you can do anything you want to a math equation as long as you do it to both sides. Minus the ln of 1.05. That's going to give me that t equals ln of 2 over 0.05 minus the ln of 1.05. Alright, notice I didn't plug ln of 2 into my calculator yet, or ln of 1.05, because you only want to round one time at the end. So I want to plug this thing into my calculator just as it looks there. Okay? Let's clear it out, and so I want to go with the ln of 2 divided by, and I've got some things going on in the bottom, so I want to put that in a, I want to put my total denominator in a parentheses. So 0.05 minus ln of 1.05. Alright, close the natural log parentheses, close the denominator parentheses, and we're going to get about 572.93, let's say. So about 572.93. Now what does that number mean? So we were solving for t, which is the number of years that it was going to take for this account compounded continuously to equal to twice this account compounded once per year if we put in the initial the same initial amount P naught. So notice that the P naught canceled out, so it didn't matter whether you put in $5 or 5,000 or 100,000. It's going to take 572.93 years for the account compounded continuously to equal the account to equal twice the account where we are compounding once per year. And I suggest that you check that number, actually plug 572.93 into t here, and let P naught be 1, say $1, and plug, and so it's going to be P naught is 1, so it's just going to be 1.05 raised to the 572.93, and again let P be $1 there, and raise it and go e to the 0.05 times 572.93, and you will see that you get the amount that you get here will be twice the amount that you get there. Alright, thanks for your attention. See you in the next video.